All right, we are on page 484, and we're going to be finishing up on 486, and then we'll have an assignment after that. So we're focused on activity 3 and talk the talk. What we have here is we've been working on graphing points on a scatter plot, and it was this for this person Mia, her weight and height for when she was younger. But we have this new information. This is now showing Mia's growth from age 2 to 5.5. So we have the age here, but we also have the age in months is what we've been looking for here. So, right, 2 years old is 24 months in age. And then we also have her weight in that time and height. So we're going to see if we can, and now that we have more information, can we create a new line of best fit and use that information. So I highlighted it here, and I'd like for you to plot. We're now plotting the Mia's weight in these varying times, so like 24 and 27.3. I have these points already drawn in red, so what I'd like for you to do, pause it here, and go ahead and put these 6 additional points for these 6 additional rows that we have, and then we'll go from there. Okay, so pause the video here, plot these points, and then we'll move on to number 1B. All right, but I'm going to continue here. So we have right this data set that's graphed, but 1B is draw the line of best fit, then determine the equation of the line. I think a good line, or a good line for anything is where half the points are above, half the points are below. We're going to draw this right here. Let me have a line from here. Let's have it go something like this. I think about half the points are above and half the points are below. Okay. All right, so we have points that are above right over here, points that are below, these points, and then these points. That's about half. Now, for this, I'm actually just going to give you the equation of the line. Right, typically you would find right where it crosses the y-axis, and then right find some points and find the rise and the run, and then we would write the equation from there. But for this, at least, I'll give it to you. So we're going to have some decimals. That's what makes it somewhat hard, but you should have an equation that's roughly close to this, y equal to 0.52x. So the slope is about half, right, 0.5. Not exactly, because when we work with real numbers or real data, right, it's somewhat messy. We don't get nice whole numbers. And the y-intercept where it crosses the y-axis is about, we're going to say 12.47. Now, let's say, you determine the equation of this line, and you get something like this. You don't have to write this part, but 0.5x plus 12.5. Like, that works as well. Where we talked about how it's impossible to draw an exact line of best fit just by kind of eyeing it. But as long as you get something close, it's acceptable. Okay. But we're going to use this. So in this case, we have to interpret. So it says interpret the slope and the y-intercept. So the slope of the line, we'll say slope, is 0.52, right? That's in front. That's our coefficient for x. So that means Mia gained an average of, well, we'll say, gained about half a pound every month. Right? Is it exactly that? No, that's what we say about. And this is for her age. We'll say from 0 to 5.5 years old. Okay, so who knows what happens after that? Maybe it plateaus, maybe it increases. But at least using the data set, that's what we get. And then for here, we do have to interpret the y-intercept. So the y-intercept, is 12.47, 12 and 47 hundredths, which means that she weighed approximately, I'm going to abbreviate there, 12.5 pounds at birth. Okay, now 12.5 pound baby is huge. So we're just gonna say in parentheses, which she didn't, right? So there are some errors kind of in this prediction, right? We can even see right here, like she would have weighed, right? Maybe if this is 4, maybe like 5 pounds, maybe 6 pounds. But we have that on the other table, but that's what it tells us at least. So maybe that's not super reliable, but we can use this prediction for other parts. Now, we're going to move on to the next part, which is height. So we're still using right our months, but we're going to use height, what I have highlighted in green. And you would most likely just flip back and forth, but I already have it pre-graphed here. So for this, you're welcome to stop the video here and graph this on your section. All right, so I'll give you some time for that. All right, we've got 6 additional points. I'm going to zoom out. So we did number 2A. Now we're going to draw the line of best fit. It's going to be somewhat like, let's say, a line that best fits this data set, somewhere like this. I think that might be a good line. Okay, and again, right, we would right find the y-intercept where it crosses the y-axis. We'd find 2 points, find the rise and the run. But for this, the purposes of this, I'm just going to give you the equation. A complex equation, y equal to 0.38x plus 22.66, 66 hundredths. So this is, again, the last one was in terms of weight. This is in terms of height. So let's interpret that before we get to any other calculations. So the slope of this, slope is 0.38, 38 hundredths, which means Mia grew, right? This amounts in terms of inches every month. Let's just say per month. Right, so she got that much taller, between 1/3 and 1/2 an inch every month until, right, from birth to, and this is about 5. Okay, and then the y-intercept, so the y-intercept, I'll abbreviate there, is 22.66, which means she was this tall. She was, so that means Mia was 22.66 inches tall at birth. And we're just going to say in parentheses, right, she wasn't. Right, 22 inches, that's almost 2 feet. So that's 2 rulers put together. That's a long baby. So, right, maybe not a best prediction for that. But we can use this to make other predictions as she gets older. So for number 3, use the new lines of best fit to determine 2 things, Mia's height and weight when she turns 18 years old. And 18 years old, that is 216 months. Okay. All right, so let's go and put, for the equation for height, that was y equal to 0.38. Instead of times x, it's going to be times 216 plus 22.66 hundredths. So that is in terms of, we'll put height. And we'll put weight over here. The other equation, in case you forgot, it was y equal to 5.52 times the same number, 216, plus 12.47. All right, so let's go ahead and do some multiplication. We can use a calculator. Let's multiply for this first one. 0.38 times 216, that is 82.08. And then we'll add that to a number that's close to 23. All right, so we're gonna have y equal to, that is 104, right, inches, but we're also gonna have 47 hundredths of an inch. So this is, so 104 inches. If you're wondering, we typically measure our height in feet. This is about 8.7 feet. We'll put the marking for that for feet. Well, it should be feet, and then this is inches. So 4 foot 7 inches. So is that reasonable? A person that's 8 feet. Last time we got someone, I think was like, it was 12 foot, right, going taller than the class. Anyways, we'll analyze that a little bit more later, but let's go ahead and multiply for the next one. That is 0.52 times 216, which is 112.32 plus, right, 12.74. This is 125.06, and this is in terms of pounds. So at 18 years old, Mia is about 125 pounds. So number 4, how do these predictions compare to your previous predictions? Are these predictions more reasonable? So I think last time we had Mia weighing at 18 years old. Her height was 12 feet, and her weight was like 190 pounds. So that was like a lot in both senses. So this, maybe it's not exactly, but we're going to say that this is, right, probably more reasonable. Right, for the weight, for weight. But we're going to say that this is, but not for height. Right, I don't think Mia's going to be 8 feet tall. Like no one, as in, well, I mean, you might have someone, no, you might, maybe just like 7 feet is like probably like a basketball player. So 8 feet is just kind of a little bit too tall. So that would be an outlier if we were to think about it in those terms. So number 5, do you think that extending the lines of best fit for Mia's weight and height over time helped to make predictions about her weight and height beyond 6 years? This we're gonna say is no, right? We would need more data. Right, so the rate of Mia's weight and height will change over time, but not at a constant rate. Right, she's not going to keep growing at the same rate. So we would need to maybe collect it beyond 6 years. Number 6, propose a strategy for developing a more accurate model for Mia's height and weight over time. We're just going to say collect more data values beyond, I think the max we had was 5.5 years, so beyond 5.5 years. Right, we'll redraw the line, we'll determine a new equation. But at least with that, this tells us, right, whenever we have data, maybe we have certain things that are missing, we have to revise our models. Right, this goes for, right, scientists, this goes for researchers, this goes for, right, maybe people in more technical fields. Right, sometimes they have only part of the puzzle, but not the entire thing. Anyways, so this was an exercise in creating and making predictions. So let's move on to the last part for talk the talk. We'll go through this somewhat faster. This says, for each graph, determine the error in the line of best fit, then sketch another possible line of best fit. So we have this blue line here. Now, if I draw a circle around this data set, is that line following the trend of the circle and the points? And is it cutting it in half? It might be cutting it in half, but I think this line, the error, is that it is too steep. Right, the slope is too steep. It might be going through half of it, but I don't think that is cutting the cluster in the way that it was intended. So let's draw a new line. I think somewhat like, it might just go through the origin. I think this is a better line. So go ahead and draw the line here. You don't have to draw the circle. Sometimes the circle just helps us. But the error for that was that it was too steep. Okay. And then for this, we have a negative association. Let me draw. If we draw the circle, there's a point over here. So this, yeah, sure, the line's in there, but it's not really halfway. It looks like all the points, we'll put the error. The line is above the data values. So if I just take that line and maybe just shift it down, so let me actually, well, whoops, let's copy that line. If I just take that line and move it further down, maybe someone like this, I think this is a better line. About half the points above, half the points below. It's parallel to the original line. Let me put an arrowhead like that. All right. So a little bit of exercise on drawing lines of best fit, but let's go to our assignment. Our assignment for this, we're actually not doing too much on the front side. We're only doing number 1A. So we're going to cross off B and C. So we're just we're finding the rate of change or unit rates for this data set. And then we're doing all of number 2. So number 2A, B, and C using this data set that's already graphed. That's it. So really it's just 4 problems. Okay, let me know if you have any questions.